And so first thing first, we have A is 1, B is -1, and C is -4. Because A is not 1, what do we have to do when A is not 1? Make a box. Let's make our box. This is only when A is not 1. So this term right here, that will always go in the top left square. So put 5x squared. And then C, that will go in the bottom right square. So let's make our X. On top of the X, we're going to put A times C. That's 5 times -4. Put that on top. 5 times -4. So we have -20. B is -1. So this is not the hardest part, but is the most important part of factoring. Find two numbers that multiply to -20, but add to -1. Don't say it out loud. Hold on, Miss Student. Give everybody a little bit of time. Let's all make sure we can find these numbers. If you need your multiplication chart, I have extras. They have to answer both questions. Okay, Miss Student, what's the numbers? -5 and +4. So that would be my two numbers that I'm taking out, and I'm putting them here and here. So I'm going to put those in the other two squares. And now we're taking out our GCFs. Now, when I'm going this direction, first I'm going to look at these two squares. And only those two squares. Do you see how both of those squares have a 5 in there? Yes, no. What else can I take out that's in both of those squares? X, okay. So I'm taking out a 5x. All right, now let's look at these two squares. What number do both of those have? A 4. So let's take out the 4. It has to be a positive because it's next to something. Whatever the sign of this next box, whatever the sign of the box is touching has, it's going to have the same sign. Okay, so now we're going to look at our columns. Looking at these two, I can't take out a number, right? But what can I take out that they both have? Just the X. And then lastly, keeping in mind that whatever I take out of these two squares, it has to multiply by this to give me this. So in other words, whatever I take out has to multiply by a positive 5x to give me a negative 5x. And it has to multiply by a positive 4 to make me a negative 4. So, Stefan, -1. That's my factors. So if it only asks you to factor, you would stop right there. These are your two factors. But it didn't. It said solve it. So you have to go one more step. Set both of these equal to 0. And get your two solutions. Leave them as a fraction. If it's a fraction, just keep it a fraction. I will accept decimals, but you don't have to change it for a decimal. So for this first one, I have to subtract 4. So that would be 5x equals negative 4. And then I have to divide by 5. So I'm just going to leave it negative 4 over 5. You can also say that x is equal to negative 0.8. But again, I generally just leave it as a fraction. I would accept either answer though. My second solution, I just have to add the 1. So x equals 1. So these will be my two solutions, and I have finished it. So we only have 3 questions left in our notes, and then we will have time to just focus on finishing homework 4. So let's go ahead and go to our notes. I think we're on page 19. We did all, oh, okay, my bad. 21, I was trying to guess without looking at it. We're on page 21. So we have a quadratic has an A, a B, and a C. Does everyone see how this one only has 2 terms? So you need to figure out, do I have A and B or A and C? I already know that 3 is A because that's with the x squared. But what is this term? Who says it's B? Who says it's C? All right, looking at the format, notice that B is always in front of just the plain old X. But C doesn't have an X at all. And if I zoom in, there's actually a negative 1 in front of the X. So this is 3x squared minus 1x equals 0. So these would be A and B. So what I want you to write in your notes is that when there's an A and B only, all you can do is take out the GCF. We don't need to make a box. We don't need to find numbers that multiply and add to. That's all we can do. That's why it's important that you recognize that that's B and not C. Okay, so 3x squared means that we have 3, and then we have 2 x's, and then I have a minus 1x. X squared simply means that there is an x times x. So looking at this, what do I have in my green group and in my pink group? That's it. That's the only thing that they share. So I'm going to take it out. That's my GCF. The GCF is X. Inside of my parentheses, I'm going to put what I have left. And what I have left over is 3x and minus 1. So we're putting them together. So that would be my factors. So right here where it says factors, let's just write that. That's your factors. All right, now let's set them equal to 0. So I'm going to take just my x, set that equal to 0. Well, that's already solved. X equals 0 is my first answer. We don't need to solve it because it's already solved. And then I'm going to take the 3x minus 1 and set that equal to 0. Go ahead and solve that. Leave your answer, keep it a fraction or make it a decimal. So I'm adding the 1. And I'm dividing by 3. So x equals 1/3 is my second solution. Now you won't be asked to graph anything like this on the actual test because these two answers are super close together. 1/3 is the same as like 30 cents. 33 cents, okay? And if you think about it, $0 and 33 cents, they pretty much close together. So on the number line, in order to graph it, I got to zoom in really close. 0 would be here, and 1/3 would be like right there. So don't worry about graphing this question. It's just way too close. If I zoom back out, see, you can't even tell. It looks like 1 point. So don't worry about graphing it because they're too close to worry about graphing. You won't be asked to graph anything that close. Any questions? All right, the last pattern we're going to talk about is the difference of two squares. So page 22. So we always have to set it equal to 0. So I have x squared equals 25. That doesn't equal 0. It has to equal 0. So I'm going to subtract 25 from both sides. And that's going to give me x squared minus 25 equals 0. All right, let me put this back up here. So again, I only have two terms. Do I have an A and a B or an A and a C? A and a C. This is the difference of two squares. This is a pattern. The difference of perfect squares. So what you do when you see this pattern, we don't need to make a box. We don't need to make an X. If you look at your multiplication chart, notice that you have a diagonal line. Those numbers are called perfect squares. Okay? Perfect squares are numbers that multiply. So for example, let me make a couple. So a perfect square would be 1 times 1 is 1. So 1 is a perfect square, obviously. 2 times 2 is 4. So 4 is a perfect square. What's 3 times 3? 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So when you look at these numbers, these are called perfect squares. When I look at this pattern, do you notice that I have a 1 and a 25? Are both of those numbers in my list?
Yes.
Yes, so that means they're perfect squares. And the word difference, can you write that this difference, that means subtraction? Anytime I'm asking you what's the difference, I'm asking you to subtract. So if you have two terms that are perfect squares separated with subtraction, then we can factor it with the pattern. And here's the pattern. We're just going to go straight down here. The only thing that you can multiply to get x squared is x times x. Put that in the front. All right. To get the 25, what number did I have to square? 5. Put that in the back. And then one has an addition sign and the other one has a subtraction sign. That would be your factors. Set both of those equal to 0 and get your 2 answers. So you should have x equals -5 and x equals +5. So whenever we have that, there's a couple ways you can write this. In pre-calc, we would normally just put plus and -5. Okay, that means +5 and -5. But you don't have to do that. You can also write it x equals 5, x equals -5. So these are actually far apart, so we can graph it. Go ahead and put a point at +5 and put a point at -5. Count left 5, count right 5, and draw your smile. And that would be your graph. All right, one more question. Take about 5 seconds, or maybe not even that long. See if you can answer or factor number 5. Example 5 by yourself. It's already set up for you. Let me go ahead and write our first few perfect squares. This one is already set equal to 0, so you don't have to add or subtract. So the only thing that multiplies to give you 1x squared is x times x. All right, which one of these numbers do I square? 1, 2, 3, 4, 5. Which one of these squares to give me 9? 3. So put a 3 in the back. One has to be plus, one has to be minus. Set them both equal to 0 to get your 2 solutions. All right, go ahead and put your 2 points, one at +3, one at -3, and make your smile. All right, go ahead and take out homework 4. Let's work on it together. So again, the due date for homework 4, I'm changing it to Thursday. So it's not due tomorrow, it's due Thursday. On or before Thursday for full credit.